that bad. And then after, so please keep in mind you can write question in the GoToWebinar panel. Otherwise, at the end with Charlie, we'll try to see with you whether there are some points to clarify at that stage. Just to before launching the video of the demonstrator, just to highlight that the development in TraceBot have been really incremental. So we defined a milestone every year, and every year we provided a first integration system. The first one back in November 21, where we already made an integration, but in simulation, but we already could at that moment discuss and agree on interface to combine the different components and to have a first illustration of the concept. But it really helped us to share the same language in between the different partners and developers. Then a year after, we had the first demonstrator at Aztec. We were already detecting automatically the canister, but we were using some standard gripper mounted on 2UR10. In November 23, we could have a first demonstrator with the delivery of the first dexterous gripper of CEA, the other gripper being a regular one. And by the end of 24, we could have our complete system with 2 CEA gripper and making a combined demo combining different part of the stability testing process that I will show you right now. So in this video that I will launch now, we will see a set of different manipulation conducted by the system. That is the canister grasping and insertion, the dual arm tube manipulation to insert it into the pump tray, and then the needle manipulation to insert it into a bottle. And so now that should start, and I will directly stop it. So when we start the system, we don't know where is the canister, but if you look here, as soon as the perception layer detects it, it is spawned into the digital representation. But our colleagues Clemens, well, just move away the canister so that the grasping could not be successful. So that the system detects this situation and go back to a recovery mode. And that consists in relocalizing the canister, and you have seen it moving here. So that now we have a new estimate of the location of the canister so that we can continue the process as you have already seen it in some other videos where we insert using our controller the canister inside the tray. I can mention that the video is accelerated, I think 8 times. We could still work on augmenting the velocity of our system, but as of today, we were going quite slowly. And then we start with the the tube manipulation, that requires a bit of manipulation to prepare the gripper appropriately with a clever grasping pattern to make sure that the tube is well held. And then we have a motion similar to what I presented before to insert the tube inside the holder. Then as you have seen, the needle is detected again, captured by one of the finger. So that's and we have a joint operation to enable the extraction of the cap. You have seen a different regrasp of the object is just to position the gripper in a convenient grasping mode to have a convenient grasp depending on the operation. The bottle has been incorporated, detected automatically, and then the 2 arms work together to insert the needle. And here we are. So we would have liked to continue this demonstration to see some liquid flowing from the bottle toward the canister. Unfortunately, I mean, we were getting a bit short in time to implement this element, and also we could not, unfortunately, have access to the digital API of the pump. That is not publicly available as of today, but it would have been a good extension of this activity to have this such a type of access to the interface so that we can directly interact in between the robotic platform and the pump without having to go to manual pushing of the button. Yeah. Yeah, so that's what I presented. So okay, so I just wanted to highlight with this video the capability of recovery of the system, in particular when we look at the canister grasping. So in this video, our colleagues are just moving around the canister and putting it also in a non-convenient configuration, that is an horizontal position on the table. And so every time the system detects the canister, it will verify that it is in a convenient pose. And if it's not, it will move it from an horizontal to a vertical setting, so that then it can regrasp it and bring it back. Insert it into the tray where it has to be positioned, because it's, grasping the object is one thing, but that we also have to think on how we want to use it. And here we have to handle this case, that is that to manipulate and insert the canister, it's appropriate to have it vertical. But as you can see here, the system, every time we are annoying him moving the object, is automatically recovering for this failure detected by the different verifiers that I mentioned, so that it can continue the activity and perform the insertion as we want. And the final item I wanted to highlight today is the audit trail that is generated through information collected during the execution and then provided as a PDF document as of today, that I should have access to here. So I guess you can see the PDF, right, Charlie? I can see you here. Can you knock? Yeah, okay. So globally speaking, the operation was successful. We have different type of information, such as the duration of the process, the participants, the type of modules that were involved, the status. We have some non-verbal explanation that are images from the camera that we actually use for detecting the object, but also a camera taking an overview of the scene that are automatically the image are automatically captured to be part of this documentation. And if I move down, I think around 2.4, so we see the different operations that are hierarchical. So we action 2, 2.1, 2.3, and then we see here that an action failed, that was to pick up the canister. And if we go back into this operation, go down, sorry, then we will see effectively that the grasping itself failed because we could not observe presence of the object inside the gripper. And from there, the system detects that the object is not there, and then a recovery process is automatically launched to compensate for that situation, which is basically to move backward, try to localize again the object and go back for the grasping. And at some moment, we will see here that when we try to grasp it again, as we can see on this local image, then there is some information, contact information detected, so that we are confident that the object is indeed inside the gripper, so that we can then continue with the process as you have seen in the video later on. So all that information is provided as a trace of the action that took place, and we could also imagine that this information could be also provided into a sort of web environment that will enable also to navigate into all the information collected if we want to have a better understanding of what happens at the different moment. In particular, it's interesting in development stages, but if there is an error that is detected, then it's always interesting to be able to go back to this situation to understand why the error happened. And with that, I think I will be closing my my session on presenting the outcome of the system.